So like I found this one integral and I absolutely hate it. So I thought by making this video I could like remember it for longer. So this is the integral. It looks surprisingly simple, but it has a lot of tricks up its sleeve. So let's just get into this. So basically the first part is you kind of factor out an x square here, and this becomes 1 over x square plus x square. And over here the basic concept used is x plus 1 over x whole square is equal to x square plus 1 over x square plus 2, and same thing, x minus 1 over x whole square is x square plus 1 over x square minus 2. So as soon as you see this, your brain should be going towards this, and trust me, even it doesn't happen even to me. So now you write this as 1 over x square dx, and so over here I'll go ahead and write this. So you know what, no, you shouldn't do that right now. I'll explain it to you later. So this is what you have, and now essentially what you want is to create a u substitution. Like you want to be able to substitute these two as your u's somewhere. So what you do is, if this was your u, what would your du be? Your du would be 1 minus 1 over x square, and if you were to substitute this as u, your du would be 1 plus 1 over x square. And it's quite evident that if I add these both, the x square cancels, but you don't want that because you haven't. So the thing is, you should ideally be subtracting these two. So let me just put a minus here and a plus over here. So since for like in order to get this, I have taken this to be u, and I mean du, and so essentially I need to write the denominator in terms of this. So I would do that by just writing it as, I have these two terms that I have in the denominator, so I would just take the 2 to the other side. So I would have x plus 1 over x whole square minus 2. And for this I would have I'd have to write it using this, so it'd be a plus 2. And notice if I add these two integrals, since this has a minus, the minus cancels and I get 2 over x square. So I would just multiply this entire thing by a half. And there you go, that's the tricky part. And now this is quite simple. So I would write this as, of course there's a dx everywhere. You could write this as a du by u square minus 2, and write this as plus 1/2 integration dv by v square plus 2, where u is equal to x plus 1 over x and v is equal to x minus 1 over x. And oops, let me just focus it. and this is just a simple integral. You would, I mean, so this just becomes 1 over 2 root 2 tan inverse. I mean, yeah, I just used the wrong formula. So you write this as integration du by u minus root 2 into u plus root 2, and this becomes 1 over 2 root 2 tan inverse v by root 2. And so what you do is you write this as this minus this, uh, so this creates a 2 root 2 term in the bottom. Since I need a 1 over here, I just divide by 2 root 2, and I have minus 1 over 4 root 2, and this just becomes uh, tan inverse v by root 2. And you can just substitute your u values from here. So yep.